What scientists get wrong about statistical evidence and how to fix it. Statistics helps us understand data's role in answering important scientific questions. Defining statistical evidence remains a complex issue. Professor Michael Evans explores this in his 2024 study. The field addresses estimating unknown values and assessing evidence for hypotheses. Two main statistical approaches are evidential and decision theory. The evidential approach emphasizes data-driven methodologies. For science, prioritizing evidence aligns with its truth-determining aim. Professor Evans discusses defining statistical evidence as a fundamental problem. Alan Birnbaum explored statistical evidence principles in the 1960s and 70s. Birnbaum's efforts revealed Frequentism and Bayesianism's division in statistics. Frequentists imagine statistical problems repeated independently to find effective procedures. Bayesian evidence principle compares posterior and prior probabilities to define statistical evidence. Evidence changes beliefs, requiring ordering of values using relative belief ratios. Relative belief ratios address estimation and hypothesis assessment, balancing subjectivity. Evidential approach surprisingly reconciles Frequentism with Bayesianism. Reliability of inference is assessed through Frequentist control of prior probabilities. Bayesian inference reflects beliefs while Frequentist reliability ensures scientific application.